Hi, Assalamualaikum. So today our group will present to you our group project with the title of Spotify app review sentiment analysis. Our group consists of 5 members. The first one is Nur Azrabina binti Ahmad Kontar. Second one is Hasha Fariza binti Abdul Halim. The next one is me, Intan Nur Asma Riza binti Nur Azmain. Sharifah Shamira binti Said Ahmad Zulfa, and the last one Nur Amira Amani binti Abdul Wahab. There is 7 sections actually to be presented today. First one is data background. This project is all about Spotify app review, which is formed from Kaggle. This review is scraped from Google Play Store. With each review is ranking between 1 star to 5 star. A total of 61,536 data were collected. The dataset is chosen because it contains comment reviews, rating, and thumbs up column, which can all be used for sentiment analysis. Next one, I will pass it to Hasha.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hasha Farawiza and I will be continuing on to the next part of the presentation, which is the case study. What is sentiment analysis? It is a technique that utilizes natural language processing to extract, convert, and interpret opinion from a text. Sentiment analysis is frequently used by businesses to extract customers' opinions through reviews regarding the products they sell or the services they provide. For our project, we used the Spotify app reviews dataset consisting of scraped reviews on the Spotify app with 5 attributes and 61,356 total reviews from users of the app. Why did we choose to perform sentiment analysis on this dataset? That is because users frequently express satisfaction with app services through online reviews. The same could be said for the Spotify app. Common requirements and characteristics of users about music streaming services can be identified by analyzing the ratings and text info provided through the reviews to enable developers to get an insight on what to improve and maintain on their app. Hence, our project will be using sentiment analysis to find out users' opinion regarding the Spotify app through analysis of the reviews.
Next, for problem statement, there are 3 problem statements. First, how to develop a sentiment review classification model for the Spotify app reviews. Second problem statement is how to evaluate the model accuracy for sentiment analysis. And lastly is how to visualize the result to understand customer satisfaction with the Spotify service. Next, for the objective, our group have 3 objectives. The first one is to develop a sentiment review classification model. The second one, to evaluate the methods to make sentiment analysis for Spotify app review based on the accuracy. And lastly, to visualize the result of customer satisfaction towards the Spotify service. Next, we move to methodology. This is the picture of our dataset. Next, this is the descriptive analytics of data. Next, predictive analytics by using sentiment analysis in RapidMiner. For this process, there are 13 operators that we use, which is retrieve, replace missing value, remove duplicate, nominal to text, extract sentiment, generate attributes, select attribute, set role, split data, aggregate, text vectorization, SVM, apply model, and lastly is performance.
Continue explaining on the methodology part of this project. According to the RapidMiner process in the picture, a total of 15 operators were used for the sentiment analysis process for the Spotify app review dataset. The first part of this experiment in the RapidMiner process is the data preprocessing. Data preprocessing is done on the Spotify app review dataset using 6 operators known as retrieve, replace missing values, remove duplicates, nominal to text, extract sentiments, and generate attributes, which I'll further discuss on in this video. We start by retrieving the dataset obtained from Kaggle by using the retrieve operator, where the dataset is uploaded into the RapidMiner repository beforehand and loading them into the process. Next, we replace the missing values found in the Spotify app review dataset of selected attribute in specified replacement using the replace missing values operator. Then we use the remove duplicates operator to remove the duplicate text in the dataset to prevent bias, where the model learns the same thing twice, and we treat the missing values as duplicates. Once settled, we need to identify the score for each review. in the dataset. Thus, extract sentiment operator is used for this purpose. We use the Vader technique to determine the polarity of the text and calculate the sentiment score for each and every text, or in this case, review text. Moving on, we use the generate attributes operator to construct a new attribute called sentiment, and we use the review attributes from the dataset for labeling of each review text according to its score produced in the sentiment extraction phase. The sentiment scores can be categorized into positive, negative, or neutral. The review attribute for the rating labeling, a rating of 1 until 2 indicates that the review given is a negative one, 3 is a neutral one, and 4 until 5 gives off a positive review rating.
Moving on, we use the select attributes operator, which selects a subset of attributes from the example set and removes other unused attributes. The default filter type is chosen for the operator, which filters all attributes, which means that no attributes are removed from our dataset. Then, the set role operator is applied, which functions by changing the role of one or more attributes. The attribute chosen to modify its role is the sentiment attribute, where its role is changed to label. The sentiment attribute would then act as a target attribute for the learning operators. The label is also called target variable or class for training the classification model. We can see here that the sentiments attribute is highlighted green, indicating that it has become the target variable for training the model with this data. Next is the split data operator, which is used to split the data set to 80% for training and 20% for testing the model. We can see here that the dataset has been reduced from 61,494 instances to 49,195 instances for training after applying the split data operator. The remaining is used for testing. Then, the aggregate operator is used for performing an aggregation function on an attribute. In this case, the sentiment attribute is aggregated using the count function to count the number of positive, neutral, and negative sentiments and build the data for model training. We can see here that there are 29,783 positive sentiments, 24,769 negative sentiments, and finally 6,942 neutral sentiments.
Next operator is SVM and applied model. SVM is applied to train the model. SVM is applied because this project is all about classification on the review dataset. Next one is performance vector. The performance of the model evaluated by the accuracy.
We have come to the last part, which is the result. My name is Sharifa Shamira and I will explain the result. So this slide shows the total count of sentiment from the aggregate operator. We can identify that our data set has positive sentiment the most, followed by the negative sentiment, and the least is the neutral sentiment. So this suggests that overall, users generally have a positive experience with the Spotify app, but there are still some areas of improvement that could be addressed to reduce the amount of negative sentiment. Additionally, it would be interesting to analyze the data further to see if there are any specific features or aspects of the app that are consistently associated with the positive or the negative sentiment. This information could be used to guide further development and updates to the app to better meet the needs of its users. Okay, next is the confusion matrix, which is a table that is used to define the performance of classification algorithm. It used to evaluate the performance of the classification model. It is mainly used to evaluate the accuracy of the model. It contains information about true positive, false positive, true negative, false negative, true neutral, and false neutral. So from the table, we can see that the actual positive and we predict positive, which is TP, is 5975. The actual negative and we predict negative, which is TN, is 4936. And the actual neutral and we predict positive, which is FP, is 1388. So this means that the model predict positive and negative is all true, but the model cannot predict the neutral sentiment and predict neutral sentiment as positive sentiment, and we achieved the accuracy of 88.71% for this model. This slide shows the detail of the calculation of confusion matrix. true positive rate is a measure of the proportion of actual positive cases that are correctly identified as positive by the classification model. In the calculation, we get true positive rate as 1. True negative rate is a measure of the proportion of actual negative cases that are correctly identified as negative by the classification model. And in the calculation, we get true negative rate as 1. True neutral rate is the measure of the proportion of actual neutral cases that are correctly identified as neutral by the classification model. And in the calculation, we get true neutral rate as 0, means that the model cannot correctly identify the neutral sentiment. So the bottom, false positive rate, is a measure of the proportion of actual negative or neutral cases that are incorrectly identified as positive cases by the classification model. So for false positive rate, we get 0.2195. So false negative rate is a measure of proportion of actual positive or neutral cases that are incorrectly identified as negative by the classification model. So for false negative, we get 0. This means that the classifier correctly identified all positive cases as positive. So false neutral rate is a measure of the proportional of actual positive or negative cases that are incorrectly identified as neutral by the classification model. So for false neutral rate, we got 0, means that there were no instances where classifier predict a positive or negative outcome for a neutral case. In conclusion, the Spotify application displayed the most positive sentiment, followed by negative sentiment and neutral sentiment. This means that Spotify received the most positive feedback from the users. So for users who are looking for a music app, can consider Spotify, which has a lot of positive feedback. But despite the fact that negative sentiment is lower than positive sentiment, but the sentiment count of negative sentiment is nearly as positive sentiment. So thus, the person in charge of Spotify should conduct more detailed research on the specific issues that are causing negative sentiment in order to implement targeted solution to improve the user experience.
That's all from our group. Thank you.